Dear students, today we'll discuss about potentiometric estimation of an FAS. So, in the potentiometric estimation of an FAS, FAS is a ferrous ammonium sulfate, which is commonly called as Moore salt, which is also called as which is having a molecular formula of FeSO4, NH4 twice of SO4, 6 molecular of hydration. Now, which contains Fe2 plus ions in the when it is made an aqueous solution. So, potentiometer is an instrument which will be used to detect the difference in the potentials of any two metal ions, different metal ions in different oxidation states, and the EMF of the system is noted with the help of an instrument. That instrument is nothing but is the potentiometer. Now, in this redox titration, which will be carried out potentiometrically using an platinum and an calomel electrode combinations, which is similar to an acid-base titrations. Now, in the titration of ferrous ammonium sulfate solution with the standard K2Cr2O7 using dilute sulfuric acid, the ferrous ions are getting continuously oxidized when ferric ions. So when you add an incremental quantities of the dichromate solution into a beaker containing Fe2 plus ions, continuously Fe2 plus getting oxidized to an Fe3 plus ions, and hence the concentration of Fe3 plus ion goes on increasing. So Fe3 plus is a very smaller ion as compared with the Fe2 plus ions, and it can migrate to the electrode faster. So as the concentration of Fe3 plus increases, the EMF goes on increases. So here the electrode system which is used is the one of the electrode system is an indicator electrode, which is also called as a redox electrode, and which redox electrode is one which can able to detect different metal ions in different oxidation state and in different concentrations. So depending upon the concentration of one metal ions which with respect to its counter metal ions, so the ratios of the concentrations it can able to detect. So such electrodes are called as a redox electrodes, or a platinum electrode is one of the electrode, and it is also called as a. So in the process of finding out the equivalence point, the potential of the redox electrode is determined with the ratio of Fe3 plus and Fe2 plus formed in the solution. So the formula potential will be usually plus 0.68 volt for 1 molar of sulfuric acid with respect to standard hydrogen electrodes. Now, when you add potassium dichromate Fe K2Cr2O7 into an Fe2 plus ions, which is getting oxidized to an Fe3 plus ions. So in a reaction, dichromate, that is nothing but Cr2O7 minus, which is present in the solutions, reacts with 14H plus with 6 Fe2 plus and converts into an 6 Fe3 plus and plus 2 Cr plus 3 with the 7H2. So when you add incremental ratios of dichromate into an Fe2 plus ions, Fe2 plus is oxidized to an Fe3 plus ions, and in the solution chromium plus 6 is reduced to chromium plus 3. So an oxidation of Fe2 plus into an Fe3 plus takes place, and simultaneously chromium plus 6 is reduced to chromium plus 3. So Cr2O7s are reduced to chromium plus 3 ions by an Fe2 plus ions. Thus the ratio of Fe3 plus by Fe2 plus gradually increases. Now once the when it increases, EMF of Fe3 plus by Fe2 plus system also increases in accordance with the Nernst equation. Nernst equation is nothing but E is equal to E naught plus 0.0591 divided by N. N is here in 1 log of Fe2 plus log of Mn plus in the solution when dichromate is added to an FAS solutions. Now this occurs till the end point. Let us consider the situation where 5% of Fe2 plus is converted into Fe3 plus, 10% will upon adding 0.5 cc then you add 1 cc, again 5% will convert Fe2 plus. Likewise, a situation will come where the 99.9% of Fe2 plus ions are completely converted into Fe3 plus. So there is a sudden conversion, sudden change of Fe2 plus into an Fe3 plus, and hence you get a sudden EMF. And in the whole of the solution, um, only you find Fe3 plus ions, not the Fe plus 2 ions. So a smaller ions which can migrate to the electrode in faster, so you will get a more EMF. After the endpoint, you are continuously adding Cr2O7 minus, that is dichromate, in the solutions, and platinum will immediately shift from Cr2O7 minus, that is chromium plus 6 by chromium plus 3 system after the endpoint. So you have to determine the endpoint by plotting delta E versus delta E by delta V versus volume of K2Cr. Now instrumentation, as I said, a potentiometer consists of an indicator electrode, which is a platinum electrode. The speciality of platinum electrode is able to detect different metal ions in different oxidation state and in different concentrations. And caramel electrode is the reference electrode. Now both these electrodes are coupled and connected to a potentiometer. So you can see from the figure, an analyte solution, that is ferrous ammonium sulfate solution, is taken in a beaker, and in the burette dichromate solution is taken continuously. 0.5 cc of dichromate solution is added, and calomel and platinum electrodes are coupled with each other and connected to a potentiometer for recording the EMF of the solution. Now procedure for performing the experimentation. So the first is you have to pipette out to 25 ml of ferrous ammonium sulfate solution. Known quantity of any known quantity, 25, 50, even you can pipette out 100 ml of FAS solution into a 250 ml beaker, and one test tube full of dilute sulfuric acid is added, and calomel and platinum electrode assembly is immersed into it. Now these electrodes are connected to the potentiometer, and from the burette, standard solution of dichromate is added in an increments of 0.5 cc, and when you add into the beaker, you have to stir the beaker and mix the contents well and record the change in the potential. So this you have to do it continuously, add 0.5 cc continuously from the burette and record the change in the potential of the potentiometer. And when you after the endpoint, you have to record at least 4 to 5 readings, and then a graph of delta E by delta V versus volume of K2Cr2O7 is plotted to determine the equivalence point. By knowing the volume of K2Cr2O7 from the graph, normality of K2Cr2O7 is given, and volume of ferrous ammonium sulfate which you have pipetted out is known. Normality of ferrous ammonium sulfate solution is calculated. So is observations, volume of ferrous ammonium sulfate solution taken which is known, and normality will be given, usually 0.25 and 0.5 normal solutions, so it will be employed during this oxidation and reduction reaction. Now initially the volume of K2Cr2O7, that is fixed, 0.51, 1.52, so on. EMF, zeroth EMF you have to record, and delta E is nothing but E3 minus E2, E2 minus E1, E1 minus E0. So delta E is the difference in the EMF of the consecutive readings. Delta V will remains constant because you are adding 0.5, 1, 1.5, so on, and ratio you have to calculate with respect to delta E by delta V. And the graph is looks like this. The graph is delta E by delta V against volume of K2Cr2O7. So graph will be like this, and at the sudden change in the potential, you will get a very sharp peak, and this peak is the equivalence point. You have to draw a line from the equivalence point to the x-axis to find the equivalence volume, that is in cc. That equivalence volume will give you the volume of K2Cr2O7. So normality of ferrous ammonium sulfate, FAS, N of FAS, is very easy using a general formula of N1 V1 is equal to N2 V2. Here N1 is ferrous ammonium sulfate, N2 is the normality of K2Cr2O7, V2 is volume of K2Cr2O7 which can be obtained from the graph, and divided by V. This V is the volume of the ferrous ammonium sulfate which you have pipetted out. So normality of K2Cr2O7 solution is given, and volume you have to find out from the graph, and volume of ferrous ammonium sulfate pipetted out will be known. So you can easily calculate the normality of ferrous ammonium sulfate, which is so much of normal. So once you calculate the normality of ferrous ammonium sulfate, amount of FAS will be calculated by multiplying with the equivalent weight of the ferrous ammonium sulfate. Equivalent weight of ferrous ammonium sulfate is 392. So once you multiply, you will get amount in so much of liter. So result is amount of FAS in the given solution is equal to so much of gram per liter. So this is the simple instrumentation to find out the normality and the amount of FAS, ferrous ammonium sulfate, in the given solution. Thank you.